In section 2.5, we're going to expand a little bit on what we know about solving equations, this time in order to rewrite and use what we call literal equations, and also formulas goes along with that. So that first problem we can maybe look at in class and try, but that's kind of introducing what we're going to be looking at, and that's using literal equations, which means that we're using two or more variables. So up till now we've only been using one at a time, but again with formulas and literal equations you can expand on that. When we work with those literal equations, we can still use the methods we've learned from our earlier sections because we're still isolating. This time it's going to say any particular variable because, again, we have more than one. So in those practice questions, if I'm given 4 equals 2m minus 5n and it asks me to solve the equation for m, and then we're also going to have to figure out what values m is going to be when n is negative 2, when n is 0, and when n is 2. So now I have two variables, m and n. And when it says to solve for m, that means I want to isolate the m variable. So in my steps here, we can start with that equation that they tell us, 4 equals 2m minus 5n. Still following the same steps that we already know. So inverse of subtraction is addition. I'm going to add 5n to both sides because, again, we want to look to get m by itself. So if I add 5n, that's going to get rid of the negative 5n on this side. In our next step, it looks like I have 5n plus 4 equals 2m, again because it's going to cancel on the right, and I had 5n on the left. Next thing you want to do is divide by 2 because, again, if I'm still looking to isolate m, I can isolate m by dividing by 2. 2 times m, opposite is division. So my final answer I can just leave as that entire fraction, so 2 terms on the top, 5m plus 4, and on the bottom I just have that divided by 2. So that's the first thing we were asked for, so we solved that equation for m. We got m isolated all by itself on the right. And now if I want to find out what the value of m is when n has these three values, negative 2, 0, and 2, now I can just take this equation we made and substitute in those three values. So I have my work there for that. When n is negative 2, again I just take my n variable from that first equation and replace it with a negative 2. So if I multiply 5 times negative 2, I get negative 10. And I have the rest of that equation, add 4, negative 6, and then divide by 2, I get negative 3. Same steps when n is 0. I'm going to substitute instead of n, now it's a 0, so 5 times 0 is going to cancel, it's just nothing. 4 over 2 becomes 2. And last one, if I plug in a 2 for my n variable, so when n is 2, 5 times 2 is 10, 10 plus 4 is 14, and then I divide by 2 to get 7. So those are my three values of m, negative 3, 2, and 7, and that's when n is negative 2, 0, and 2. So three different values that we use for n means there's going to be three different values for m. So trying that again with the next question, it's really the same equation, so 4 equals 2m minus 5n, but now it's asking us to substitute first and then solve. So last time we solved to get m by it first, and then we substituted those three values. And I'm just going to show my work for that one. So that's taking that first equation, 4 equals 2m minus 5n, but remember we substitute at the very start. And the issue about doing it this way, so notice I can still plug it in, negative 5 times negative 2 is 10, and then I follow my same steps, so subtract both sides by 10. I'm looking to isolate m. So last thing I have to do is divide by 2. So we can still get our same answer. Notice when n is negative 2, m is negative 3. We saw that from the last question. When n is negative 2, m is negative 3. But the issue here is that we have to solve it 3 times. So I have to substitute and solve for m. Substitute 2 and solve for m. So when it's asking you, do we prefer this method or the method used in the first question, it's still up to you, but I think I would prefer that first method because we only have to solve the actual equation once. We only have to isolate our variable once. And then after that, I'm just substituting and simplifying. As opposed to doing it the second way, we have to follow those same steps every time, those inverse operation steps, and we still have to substitute. So I would prefer first method, but it's really up to you when you solve it. Next little part down here, when we rewrite literal equations, we may have to divide by a variable or variable expressions. We didn't have to do that up here, but we may have this. When we do so in this lesson, this is just to assume that any variables that we divide by are not 0, because again, I can't divide by 0, so it's not defined. So if my n variable is 0, I wouldn't want to divide that by 0. So looking at our next side, what equation do we get when we solve negative a equals b plus cx for x? Remember, when it's asking us to solve for a variable, that means that we want to isolate x on one side of the equation. So starting with our equation, negative a equals b plus cx, First thing I want to do is subtract b on both sides, because again, that'll get rid of this term on the right. If I'm looking to isolate x, I want to get rid of everything else on this side. So after I've subtracted b on both sides, I have negative b minus a equals cx. Next thing I want to do is get rid of the c, so I do that by dividing. So this is where, again, we have to assume that c is not 0, because if it was, you can't divide by 0. But if it's not 0 and I can divide, it's going to cancel on the right. On the left, I'm just left with negative b minus a over c equals x. That's my answer because, again, we've isolated the x. Got that all by itself on the right-hand side. So a formula is an equation that states a relationship among certain quantities. Formulas, special types of little equations. Some common formulas that we have are below. We're going to be using these relatively often. Notice that some of the formulas use the same variables, but the definitions are different. So let me see if I can find an example. Like right here in our second formula, we have an r variable. We also have an r variable in this formula. But notice they mean different things. When we talk about circumference of a circle, it's the radius that r is referring to. When we talk about distance traveled, it's the rate. So it does depend on the formula what your variables mean, but that's always a good idea to list what your variables are referring to. And just want to fill in these blanks, so we're going to use perimeter of a rectangle equation, circumference of a circle, area of a rectangle, area of a triangle, area of a circle, so all three area formulas that we're using, distance, and temperature. So based on what kind of word problem you're getting, you're going to want to use that right formula. So those are written here. Let's try that with a practice. If I'm trying to find the height of a triangle that has an area of 24 square inches and a base with a length of 8 inches. So first thing you want to do, kind of like what I did in this question, is pick out what's important. We want to find the height of a triangle. So we're already looking at maybe a triangle formula. And if I already know the area of the triangle and the base, I'm taking this formula. So let's look at my work here. We're using that triangle area formula equation. I know the area is 24. And I left units out of this first one, but you can also include units at the start to remind yourself. Know the area is 24. We know the base is 8, so we have to figure out the height. So first thing we do want to do is list what formula we're using. This is our triangle area formula. Area is 1/2 base times height. So first thing you want to do is to isolate what variable we want. So if I'm trying to find height, let's see if we can get this h variable by itself. And first thing I want to do is multiply both sides by 2. That's going to get rid of my fraction on the right-hand side. So if I have 2a equals base times height, last thing I have to do to get height by itself is divide both sides by the base. So if I have this formula now, 2 times area over base is height. Now, just like that first question, all I have to do is replace with my variables. So if I know 2 times the area, if I know the area is 24, I can substitute 24 for a. If I know the base is 8, I could substitute 8 for b. And now I can just simplify. 2 times 24 is 48, and 48 divided by 8 gives us 6. And after I've got my answer, I just got to make sure that we use our units for a word problem. So 6 inches for your height. And trying that again here, have a little bit of a longer question. So we have gray whales that are migrating from Alaska to Baja, California. So let's pick out what's important. The whales travel a distance of about 5,000 miles each way, and they take about 91 miles per day to do that. So if we want to figure out how many days it takes to make that trip, first thing we want to do is pick out maybe which formula we're using. And again, if we're talking about gray whales traveling a certain distance, probably going to be this one right here, distance traveled. So let's take a look at how we're going to set that up. And I just made a note of that formula here. It's going to use distance is rate times time. So talking about distance and speeds. We know the distance is 5,000 miles to make that trip each way. And we also know their rate or their speed is 91 miles per day. And again, if we're asked how many days it makes to take that trip, that means we're looking for the amount of time. So first thing I want to do is take that formula, and if I'm looking to solve for time, see if we can get that t variable by itself. All I really have to do here is get rid of r on this side. So if it's r times t, opposite of multiplication is going to be division. Divide both sides by r, and now I can use this formula. Distance divided by the rate will tell me the time that I need. So now that I have my formula, I can take my pieces and substitute. 5,000 for my distance that we're using, and 91 miles per day. 5,000 divided by 91 gets us about 55 days. So again, it's always easier to solve these equations for the variable you want first. Get time by itself, substitute, and then solve. But of course, we always have the option of substituting first and then solving for t. Either way, we're going to look at this in some practice, so make sure we have this down and we'll answer any questions.